Namaskar. Welcome back to Stat Skill Hub. I'm Dr. Asha Jindal. In today's episode, we will explore the Violin Plot, a powerful graphical tool that helps understand the complete distribution of data. Unlike simple summary statistics, Violin plots reveal the shape, spread, and concentration of data in a much richer way. By the end of this session, you will understand how violin plots work, how to interpret them, and when they are useful. Traditional summary statistics, such as mean, median, and quartiles, are useful, but they do not always tell the full story. Even box plot, although very informative, mainly summarize the data using quartiles and outliers. They do not clearly show how values are distributed between those points. Interestingly, two datasets can have very similar box plots while having completely different underlying distributions. That is where violin plots become valuable because they help reveal the hidden structure of the data. Let me tell you, a violin plots combines the strength of two methods. First, it includes the familiar features of a box plot, such as the median, quartiles, and possible outliers. Second, it adds a kernel density estimate known as KDE, which shows how the data is distributed across different values. The replicated density shape gives the graph of violin-like appearance. So, a violin plot provides both summary statistics and distributional shape together in one visualization. Now, understand the main components of a violin plot. The outer shape represents the density of the data. Wider sections indicates area where many observations are concentrated. Inside the violin, we see a box plot showing the median and interquartile range. The center axis represents the scale of the variable being analyzed. Together, these components help us understand not only the center and spread, but also how the data is distributed overall. One major advantage of violin plot is their ability to reveal hidden patterns. For example, they can clearly show multimodality, meaning the presence of multiple peaks or clusters in the data. They also make skewness easy to identify because the shape becomes wider on one side. In addition, violin plots help us see where value is most concentrated, which is difficult to observe from summary statistics alone. This deeper insight makes violin plots very useful for exploratory data analysis. Next, I will discuss violin plot versus box plot. Both box plot and violin plots are useful, but each serves a different purpose. Box plots are simpler and work well when comparing many categories or presenting results to a general audience. Violin plots are better when we want to examine the complete distribution shape in more detail. They are particularly useful when we suspect multiple clusters, skewness, or unusual patterns in the data. So, the choice depends on the level of details needed and the audience we are communicating with. Violin plots are widely used across many fields. In salary analysis, they help comparing income distributions across departments or job roles. In educational research, they can show how students' performance differs under different teaching methods. In product analytics, violin plots help compare performance measurements across product versions. They are also available for anomaly detection because the tails of the distribution becomes more visible. I will demonstrate how to create this impactful violin plots using Jamovi. and then how to interpret it. I'm using tooth growth data set of guinea pigs in box plot explanation, and same I'm using it here. Again, three variables are there. Len is the length of the tooth. Supplement, two supplements are provided to the pigs. These are the different dose levels are given. For analysis, I will go to the first analysis step, then click on exploration, move to descriptives and select it, len variable. I will move to variable box. Supplement to split by, then move to plots and click on Violin Plots. I want a box plot inside this, so click on box plots as well as data. So my violin plot is created, and this violin plot compares tooth growth distribution for two supplements types, orange juice and vitamin C. The width of each violin represents the concentration of observations at different tooth length values. You can observe that both groups show variation in tooth growths, but the orange juice group appears to have slightly higher concentrations at larger tooth levels. The shape also helps us understand spread and possible skewness in the distribution. Unlike the box plot alone, the violin plots reveals how densely values are clustered across different ranges. This makes it easier to compare the overall distribution patterns between the two supplement groups. Let me move back to my presentation. Although violin plots are powerful, they should be used carefully. With very small sample sizes, the density shape may become misleading because KDE smoothing may exaggerate patterns. It is also important to guide the audience by explaining that wider sections represents greater data concentration. Another important factor is bandwidth selection in KDE. Too much smoothing hides detail, while too much little smoothing creates unnecessary noise. So, interpretation should always be done thoughtfully. To conclude, violin plots help us move beyond simple summaries and explore the full distribution of data. They reveal important features such as density, skewness, and multimodality that may remain hidden in box plots. By combining summary statistics with distributional shape, violin plots supports deeper and more informed analysis. Thank you for watching this episode of Stat Skill Hub. I hope this session helped you confidently use and interpret violin plots in your future statistical analysis.